you think yesterday ceased to exist? For Richard Feynman, time doesn't function like a line that erases itself. Science admits something that our intuition tries to deny at all costs. The past is not a ghostly memory. It is a geographical coordinate. Just as a city doesn't cease to exist simply because you left it, the moment you were born and the moment you are watching this video are both stationed in the fabric of the cosmos. Feynman taught us that time is an entire map, and we are merely travelers who can only look through a crack in the window. Prepare to understand why, in modern physics, goodbye is merely a limitation of our senses. Richard Feynman didn't see time as we do. For most people, time is like a flowing river. The past is water that has already passed us by and is lost in the sea of forgetfulness. The future is a mist that hasn't yet arrived. But science, through the lens of Feynman and Einstein's relativity, admits a much more solid and unsettling reality: the block universe. In this model, time doesn't pass. It simply is. The past is not a volatile memory that dissolves into thin air. It is a geographical coordinate. This means that the moment of your first step, yesterday, and the exact second you are reading this sentence are all stationed somewhere in the fabric of the cosmos. For Feynman, the past hasn't disappeared. It's you who have moved away from it. The geography of time. Where is yesterday? Imagine you are on a road connecting São Paulo to Rio de Janeiro. When you arrive in Rio, does São Paulo cease to exist? Obviously not. It continues to exist, with its streets, people, and buildings, just at a different geographical coordinate than yours. Feynman applied this same logic to time. Science acknowledges that time is the fourth dimension. Just as left and right or up and down are directions in space, before and after are directions in time. In the block universe, reality is like a film printed on a reel of film. If you look at a single frame, you see the now. But if you unroll the entire film on a table, you'll see that the beginning of the film and the end of the film exist simultaneously on the table. The hero doesn't die and cease to exist on the film reel. He merely inhabits the earlier frames. Almost no one talks about the emotional implications of this, but Feynman understood. The past is a place we no longer know how to look at, but it remains physically real, preserved in the eternal architecture of the universe. The lantern of perception. Why do we feel the flow? If the past still exists as a place, why do we feel trapped in a present that always seems to be slipping away? Feynman suggested that this feeling of flux is a biological limitation, not a property of physics. Our consciousness functions like a flashlight in a dark tunnel. As we walk through the tunnel, the light illuminates only a small circle ahead of us. The fact that the flashlight is no longer illuminating the section of the tunnel we have already traversed does not mean that that section has collapsed or disappeared. It remains there, solid and unchanging. Physics admits that there is nothing in the fundamental laws of nature that defines now as a special moment. To an observer outside the universe, all slices of time would be visible at once. Feynman taught us that the past is merely the name we give to the coordinates left behind in our trajectory. We suffer from the loss of the past only because our lantern lacks the necessary range to illuminate what we have already lived. But for the fabric of space-time, yesterday is as real and present as the ground beneath your feet. The persistence of matter in the past. Almost no one stops to think about what happens to the atoms that formed you 10 years ago. Science acknowledges that your body is constantly renewing itself, but the exact configuration of those atoms in 2014 wasn't deleted from the universe. In a block universe, every interaction between particles creates a permanent record. Feynman used his mathematics to show that the history of a particle is a continuous line in spacetime, called a universe line. This line doesn't disappear as the particle moves. It extends like a solid copper wire through the block of time. If you could see the universe in 4 dimensions, you wouldn't see a person, but a long temporal worm that begins at birth and ends at death. Each segment of this worm is a version of you at a different moment. Your 5-year-old self didn't cease to exist to give way to your adult self. Both coexist at different points on this eternal string. Feynman physics posits that the past is the solid foundation that supports the structure of the present. Without the physical existence of the past, the block of time would collapse. The comfort of physics. Farewell is an illusion. There is a profound and transformative value in accepting the block universe. Richard Feynman, who experienced painful personal losses, such as that of his first wife, Arlene, found in physics a kind of solace that religion often failed to offer. If the past is a place, then the people we love who have passed away have not been annihilated by time. They are, in a very real way, inhabiting the temporal coordinates where they were always happy. Science acknowledges that time is not a devourer of worlds, but a preserver of moments. Almost no one talks about this because it is difficult for our mortal minds to process the mathematical immortality of the past. But for Feynman, understanding the block universe meant understanding that no moment of beauty, no discovery, and no embrace are truly lost. They are forever recorded in the geometry of the cosmos. Time is not an eraser. It is an infinite archive. If the past is a place, then your life is not a sequence of events that disappear, but a monumental sculpture carved into the fabric of eternity. Feynman invites us to stop lamenting the time that has passed and begin to appreciate the vastness of the map we are building. Physics admits that yesterday is as indestructible as energy. We are the architects of a four-dimensional structure that will never be erased. In Richard Feynman's block universe, the past is where your history is safely stored, protected by the most fundamental laws of physics against any attempt at forgetting. Yesterday did not die. It has simply become an eternal part of all that is. Richard Feynman wasn't content with merely theorizing about time. He wanted to find the fingerprints of the past in the particles that make up our bodies. This led him to one of the most audacious conclusions in modern physics: that antimatter is not just an exotic substance or a science fiction fuel, but living proof that the past is still accessible territory. Almost no one talks about this outside academic circles, but Feynman mathematically demonstrated that a positron, the antiparticle of the electron, can be perfectly described as an ordinary electron traveling backward in time. For Feynman's science, the past hasn't disappeared because particles are constantly entering and leaving it. Stueckelberg's insight and Feynman's genius. The idea began to take shape when Feynman refined the work of Ernst Stueckelberg. He realized that the equations describing the motion of an electron in space-time allowed for a bizarre yet flawless mathematical interpretation. If you look at the trajectory of a negatively charged particle going from point A, past, to point B, future, the mathematics is the same as for a positively charged particle going from point B, future, to point A, past. Feynman didn't see this merely as an algebraic trick. He saw an ontological truth. Science admits that antimatter is the mirror of matter, but Feynman went further. It is the temporal mirror. Almost no one explains this so clearly, but for Feynman, a positron is an electron that hit something in the future and was ricocheted back to yesterday. If the past had ceased to exist, if it were absolute nothingness, the electron would have nowhere to return to. The physical existence of antimatter is proof that the past is firm and navigable ground. The Feynman diagram, the map of temporal roads. To visualize this concept, Feynman created what we now call Feynman diagrams. In them, time is represented on one axis and space on another. What we see in these drawings are lines that collide and change direction. Imagine an electron traveling peacefully into the future. Suddenly it emits a photon, light, and at that exact moment, it changes its trajectory and begins to move down on the diagram, that is, towards the past. In this section where it travels against the flow of time, we observe it and call it a positron. When it collides with another electron in the past, they can annihilate each other and become pure energy. Science acknowledges that these diagrams are the most precise tool we have for predicting the behavior of matter. Almost no one talks about the philosophical implication of this. We accept the technology based on these calculations, but ignore that they treat the past as an open dimension for bidirectional traffic. The single electron theory, a universe made of a single traveler. Taking this logic to the extreme, Feynman once received a phone call from his mentor, John Wheeler, who proposed a mind-blowing idea. "Feynman, I know why all the electrons in the universe have the same charge and the same mass. because they are all the same electron. The idea was that a single electron would be frantically zigzagging between the past and the future, billions of trillions of times. When it travels to the future, we see it as an electron. When it turns back to the past, we see it as a positron. Although Feynman laughed at the idea that there would only be one electron, he adopted the mathematics of this return journey. This reinforces the idea of the block universe. If the past is a place, particles can visit it. The antimatter we detect in hospitals, in PET scans, is, in Feynman's view, matter that is looking back, proving that yesterday is a physical coordinate as real as north or south. The arrow of time and our macroscopic illusion. If particles can travel to the past, why can't we, beings made of trillions of particles, do the same? Feynman explained that the problem isn't physics, but statistics. At the level of a single particle, time is symmetrical. It doesn't have a preferred direction. But when you put trillions of particles together, entropy, chaos, arises. It's like a deck of cards. It's easy to move a single card backward, but if you throw the whole deck up in the air, the chance of all the cards falling in exactly the original order is negligible. Science admits that the past hasn't disappeared, but for macroscopic beings like us, going back is statistically impossible. We get caught in the current, while the electrons around us swim against the tide all the time. Feynman taught us that the past is alive and pulsating just below the surface of our perception, accessible to the most basic constituents of our being. The conclusion of this topic is an invitation to look at matter differently. If each positron is an electron traveling back in time, and if your body produces and interacts with these particles at quantum levels, then you are not a being that is merely coming out of the past. You are a system where the past and the future are constantly colliding. Richard Feynman gave us the tool to understand that time doesn't erase events, it stores them. Antimatter is proof that the road to yesterday wasn't destroyed. It simply requires a scale that our human eyes cannot see. The past is not a ghost. It is the destination from which come the particles that allow us to exist in the now. Understanding antimatter is accepting that the universe is far more temporally interconnected than any of us dared to dream. Yesterday is not gone. It is making its way back right now, inside every atom. Richard Feynman was a master at understanding what the universe does with its secrets. In everyday life, we have the feeling that things disappear. A burnt letter turns to ashes. A voice dissipates into thin air. A loved one departs, and silence takes over. But science admits a much deeper and more rigorous law, of which Feynman was one of the greatest defenders. Quantum information can never be destroyed. In the court of physics, forgetting is an impossible crime. Almost no one talks about it, but for Feynman, the vacuum is not a graveyard of memories, but an indestructible archive. The past has not disappeared because the universe keeps the recipe for every second that has ever existed, and nothing, absolutely nothing, is lost in the vacuum. The law of conservation. The universe doesn't have a delete key. To understand why the past hasn't disappeared, we need to understand the concept of unitarity. In quantum mechanics, this is the rule that states that the sum of the probabilities of all possible outcomes must always equal 1 or 100%. If information about the past could simply vanish, the mathematics of physics would collapse. The universe would cease to be logical. Feynman explained that if you burn a book, the information contained in the words seems to vanish to your human eyes. But if you could trace every molecule of smoke, every atom of ash, and every photon of infrared light emitted by the heat of the flame, you could, in theory, reconstruct the entire book. Science admits that the information has only become illegible or scattered, what we call increased entropy, but it is still there. For Feynman, the past is not a ghost that has disintegrated. It is a jigsaw puzzle whose pieces have been scattered by the wind, but the pieces still physically exist in the fabric of space-time. The vacuum as witness, the quantum record. Many people think of a vacuum as nothing, but Feynman helped prove that the vacuum is actually a bubbling ocean of activity. Through quantum electrodynamics, QED, he showed that empty space is constantly interacting with matter. When you move, when you speak, or when an event happens, you are altering the state of the virtual particles and fields that fill the vacuum. This alteration creates a kind of quantum echo. Almost no one stops to think that every interaction you've had in life has left a permanent mark on the electromagnetic and gravitational fields of the universe. Physics admits that these interactions are permanent. If the past had truly disappeared, the current state of the universe would have no cause. The fact that the present exists with the exact configurations it possesses is proof that the past is written in the structure of matter today. For Feynman, the past is the invisible foundation. You don't see the foundations of a building when you look at the 20th floor, but if the foundations weren't there, the building would collapse. The vacuum is the long-term memory of the cosmos. The information paradox and Feynman's legacy, the idea that information never dies, has led physics to one of its greatest debates. What happens inside a black hole? If even a black hole could destroy information, Feynman's laws would be wrong. However, modern science, following in the footsteps of Feynman and Hawking, tends to admit that not even the most voracious monsters in the universe can erase the past. They only encode it on their surface. Feynman taught us that reality is a closed system of conservation. If your past disappeared, the energy and information that composed it would have to go nowhere, which violates the first law of thermodynamics. Therefore, your past is not a shadow. It is a structural part of the total energy of the universe. Almost no one talks about this because it is both frightening and wonderful at the same time. Every mistake you made, every tear, and every victory is encoded in the universe's background radiation. The past is not something you leave behind, it is something you carry, as it is interwoven into every atom of your present body. The value of persistence, scientific immortality. There is a profoundly technical consolation in Feynman's view on the preservation of information. In a world where everything seems ephemeral, physics admits that ephemerality is an optical illusion. The now is merely the tip of an iceberg of information that extends infinitely backward. Feynman argued that nature is honest, it throws nothing away. The fact that we don't have the technology to read the information scattered in the ashes of time doesn't mean the information doesn't exist. This changes our relationship with time and with loss. If nothing is lost in a vacuum, then the history of the universe, and your personal history, is an indestructible monument. Science admits that the trajectory of every particle is preserved. The past hasn't disappeared because the universe is a system that doesn't know forgetting. It's a book where the pages are never torn out. They are only written with an ink that becomes invisible to those who don't know how to look. Climax: the universe as a finished work. The conclusion of this topic should be a shock of clarity for the viewer. If information cannot be destroyed, then time is not a destroyer, but a collector. Richard Feynman showed us that the past is stored in the hardware of reality. Science admits that the vacuum has memory. Almost no one talks about this because we prefer to believe in our limited perception that time erases everything. But Feynman invites us to look at the sky and at the atoms and see the truth. The past is pulsating now, encoded in light, gravity, and the very structure of nothingness. You are not a being walking towards the void. You are an eternal sequence of information that the universe refuses to delete. As Feynman proved, yesterday is not silence. It is a symphony that continues to echo in the walls of the vacuum, forever. Conclusion: the map that never fades. Richard Feynman was not just a physicist, he was a cartographer of eternity. Throughout this narrative we have seen that. The block universe shows us that the past is a real geographical coordinate. Antimatter proves that particles can swim back to yesterday. Information preservation ensures that nothing we experience can be deleted. Science admits that the past hasn't disappeared, but almost no one talks about it because the truth demands that we change our way of living. If yesterday still exists, if it's part of an eternal block, and if its information is indestructible, then every moment of your life gains infinite weight. You're not just passing through the world, you're leaving a permanent mark on the fabric of existence. Time is not your enemy. It is the museum where your life is being preserved. Feynman gave us the formulas, but the conclusion is a gift. Nothing beautiful is lost, and nothing lived ceases to be real. The past has not disappeared. It is exactly where it has always been, at the heart of the universe's structure, waiting for the light of your understanding.